Welcome back to the Backspace Academy lab on highly available and fault-tolerant architecture for web applications inside of VPC. In this lesson we're going to go through creating an RDS Aurora instance and also creating a read replica for that instance. The first thing we're going to do is to create a DB security group, a security group specifically for the RDS Aurora instance. We're also going to create a DB subnet group, and we need that to launch our multi-AZ RDS Aurora instance into. So we will be launching an RDS Aurora instance inside our private subnet in one availability zone, and that will be multi-AZ. So there will be an RDS Aurora standby instance inside another availability zone. We will then create an RDS Aurora read replica in the second availability zone, and that will be to take some of the read load off the RDS master database. Okay, so the first thing we're going to do is create a security group specific for our DB server. So we just click on Create Security Group. So we're just going to call this DB Server SG. Same with the group name there, and then we're going to give it a description there of DB Server Security and make sure that we select the correct VPC, VPC backspace-lab, and click Create. So we'll now create our inbound rules, so click on the Inbound Rules tab. The first rule that we're going to create will be for MySQL inbound requests, web server inbound requests to our MySQL RDS instance. So inbound on port 3306, and that is going to be sourced from our web server security group. And we click on Save for that. And we now go to our outbound rules, so we edit and we add port 80. And that is going to be for everywhere. And then we add another rule for port 443. And again, that is going to be for anywhere. And we click Save. Okay, so now that we've created our DB server security group, we can reference that into our web server security group. So we just click on our web server security group there, and we need to select the outbound rules tab. So we're going to edit that and add another rule, which is going to be for outbound requests to our MySQL database. So select MySQL there, port 3306, and the destination is going to be our DB server security group. So we just add that in there and we click on Save. So now that we've got our DB server security group set up and our web server security group referencing that, we can now go into our RDS console. So go into our RDS console there, and the first thing we're going to want to do is to create a DB subnet group to launch our multi-AZ cluster into. So we go into here into subnet group, and then we create a subnet group. So we're going to call this backspace-lab-subnet group, and we'll give it the same description there. We need to make sure that we select the correct VPC, so our backspace-lab VPC. Next, we need to select our two private subnets in our two availability zones that we're going to be launching our RDS instances into. So we select the first one is going to be in US East 1A, and we select our private subnet there. So that is 10.0.1.0, and we add that in there. The next one is going to be in US East 1B, and we select again our private availability zone, which is 10.0.3.0, and we add that in there as well. Make sure that we click on Add, and we have two of them down there. So our two private subnets in our two availability zones, and we click on create. So now that we've created our DB subnet group, and we can see it there, we can now launch instances, multi-AZ instances into that DB subnet group. So we'll click on instances there and launch DB instance. Okay, so the first thing we can see here now is that there is no selection there for RDS Aurora. The reason for that is that this is a newly created account and doesn't actually have access to RDS Aurora. RDS Aurora is currently, at the time of this video, only available for pre-release and by request. So for this video we'll be using MySQL, but the process is exactly the same whether you're using MySQL or RDS Aurora. So we'll just click on MySQL there. Okay, so the first thing we're asked is, do we want multi-AZ deployment for this lab, and certainly for any production purposes, you would want to select multi-AZ deployment. So we'll leave the license model there as it is. Same with DB engine version. You can select a different version if you would like. We're just going to, for this lab, we'll use the T2 micro just to keep costs down. It's a very small one, but for a lab environment, that's fine. Multi-AZ deployment. Now we've created our DB subnet group across multi-AZ, so yes, we will be selecting multi-AZ. The storage type, so this is where we can select our provisioned IOPS storage, so we can put our provisioned IOPS in there and our allocated storage. For this one, we'll just use general purpose SSD. It's giving us a warning there, that's fine. I'm just going to give it here a DB instance identifier backspace -lab -db, and give yourself a user name and a password, and make sure you remember that because we'll need it to access the database later on. So we just go to the next step after that. Okay, so now in the advanced settings, so the first thing we would like to do is to select the correct VPC, so backspace -lab VPC, and our DB subnet group that we created there. Now, very important, we want to make sure that this is not publicly accessible. So we've created a VPC, and we don't want access outside of that VPC. We only want access from our web server security group, and we look there. So we've got our VPC security groups, and we select our DB server security group. Now I'm going to give this a name of backspace -lab DB, so it's giving me a warning there. We can only contain numbers and letters, so that's fine. Backspace -lab DB with no dashes or anything like that. The database port there is 3306. We define that in our security group. We can look at here for backup and maintenance. We can define a backup window. We've selected no preference, but we could select a backup window there for backups or maintenance. Everything looks fine there, so we'll just click on Launch DB Instance. Okay, and our DB instance has been created. Okay, and thanks to the magic of pre-recorded video, it takes about 5 or 10 minutes for the instance to be fully created and for the backups to be created and all that sort of thing. So we can see here we have our configuration details of our actual database. So we've got here the database name, our username for logging into that database, and we must remember our password for that. We can see here it's been the master database has been launched into US East 1A. And then we've also got our DB subnet group there. We've also got the two subnets, so we'll just click on those and have a look at them and make sure that they are actually our private subnet number 1 and number 2. So just going into there to have a look at those. I'll open them opening in a new tab. Okay, so that's private subnet number 2, that is fine, and the next one should be private subnet number 1. Okay, and that one there is private subnet number 1. So we've got private subnet number 1 and 2, so that's fine that we've launched that into. The DB security group there is fine. what we've got here is our endpoint for our database instance. Now what that allows us to do is we use that to connect into our that endpoint to connect into this database. So in our web application such as WordPress that we've created here, we would use that endpoint as the database location. So next thing we're going to do now is to create a read replica of this database. So we click on Create Read Replica. Okay, so we're just going to use a read replica of the same size as the master database, so T2 micro there, and the same storage type of SSD. We put in here, we select the read replica source. We've only got one master database there, so that's fine. Going to give that a DB instance identifier, the same as a read replica, the same as a master database, but with dash replica on the end of it. So we'll just do backspace -lab -db -replica. We're going to use US to East again, the same region, and that same subnet group that we've created. Publicly accessible, no. And the availability zone is going to be in our second availability zone, so US to East -1B. And the database port is the same, and we leave everything the same there, and we create our read replica in that second availability zone. Okay, and there we can see that's happening. So we'll just minimize the master database here, so just click on the arrow there to minimize that, and we'll just open up the db-replica and have a look at that. So there we can see we've created the same backspace lab db, so the same database name and the same login username for that, but we can see here we've actually created this read replica in US East -1B, so everything's fine there. Okay, so just having a look at these two database instances. The first one, our master database, has an endpoint there that we're aware of, but also at our replica instance we have another endpoint here which is totally different. So that's going to create problems for us with our WordPress application as it's launching within different availability zones. It's not going to know which endpoint to use for its read requests. So there's a number of solutions available for that. Obviously you would ask, well, why don't we just put an elastic load balancer in front of these RDS instances in the same way that we've done with our EC2 instances? Unfortunately, AWS doesn't provide that capability, so you cannot front that with an ELB. You need to actually create a HA proxy instance in front of these RDS instances, and you would use the endpoint from that HA proxy instance to distribute that traffic to the different RDS instances. So by doing that, you would use the endpoint for your HA proxy instance, and that would be what you would use for your read requests. That is beyond what you would expect from an associate level architect course, but just be aware that is a solution to use HA proxy in front of your RDS instances. There is another solution that's a developer's solution, and that would be, and again beyond what you would expect from an architect associate level course, but we would cover this in our developers course. The developers can, upon startup of the instance, they can check the instance metadata to identify exactly what availability zone that instance is in. And so once they've done that, they can identify what is the appropriate instance to send their data to, depending on their availability zone that they're in. So there's two options there. Both of those options are, for us to understand, are beyond an associate level architect course. But just be aware that that is an issue, and those are the two solutions that are available. HA proxy is generally the preferred solution from an Amazon Web Services perspective. So that's all for now, and I'll look forward to you in the rest of the course.